Timeless concepts from physics helpline. In this video tutorial, we will discuss a multiple choice question taken from JEE Main exam of 2021. The question is about the wavelength associated with an electron and photon possessing the same amount of energy. Read the question carefully. An electron of mass m and a photon have the same energy E. The ratio of wavelength of electron to that of the photon is c being the velocity of light. The options are given in the question. We are required to find the correct option. Now for the solution. Energy of a photon is given by E is equal to h nu. We'll mark this as equation 1, where h is the Planck's constant and nu is the frequency of the associated with the photon. Now frequency is equal to velocity, because it is light or photon, velocity of light c divided by lambda of photon. Lambda p is the lambda wavelength of photon. Therefore, E is equal to, putting in equation 1 the value of nu, E is equal to h c by lambda p. h c by lambda p. From this we get lambda p is equal to, lambda p comes here and is equal to h c by E. We mark this as equation 2. We'll remove everything and put it there. Now for the electron. It is given in the question that energy of the electron is also equal to E. Therefore, energy is equal to E. Let its momentum be P is equal to mv, where m is the mass of the electron and v is its velocity. Now the de Broglie wavelength of the electron associated with the electron, which has got momentum p, is given by lambda E is equal to h by p. Lambda is equal to h by p. This is the de Broglie's formula for wavelength of any particle. Now E is equal to half mv square and P is equal to mv. Therefore, P square is equal to, let us write it here, P square is equal to m square v square, which can be written as 2m into half mv square, because 2 and 2 gets cancelled and m becomes m square v square. So p square can be written like this, 2m into half mv square, which is equal to 2me, where E is the energy. Therefore, P is equal to root over 2me. P is equal to root over 2me. Let us mark this as equation 3, and putting the value of P in equation 3, we get lambda E is equal to h by root over 2me. We'll mark this equation as equation 4. I will remove everything else, put it there. Now for the required ratio, lambda E divided by lambda P, wavelength associated with the electron and that of the photon. is equal to, we'll put the values, lambda E is equal to h by root over 2me and divided by lambda p. Lambda p is equal to hc by E. Therefore, we can multiply this with E by hc. H by. So one h gets cancelled here, giving us E by root over 2m E into C. We can write like this. Now we keep 1 by C separate and let us take under root, it becomes E square divided by 2me, which gives us this is equal to 1 by C root over 1 E gets cancelled, so E divided by 2m. Therefore, we can write this ratio lambda E divided by lambda P is equal to 1 by C into root over this. We will write this as power 2m to the power 1 by 2, which is the answer to the question. Therefore, the correct option is 2. 2 is the correct option. This completes the answer to the question. Thanks for watching.